page yet, right? We did a page very similar to this, but this is just kind of reinforcing again, what is a log? And it says when there's no base, you're going to use 10. So let's just set up the first together. So this says 5 raised to what power gives me the answer of 125. So you need your exponent rules. That's 5 cubed is 125. So see how we started to memorize kind of those power families? So the answer to number 1 is just 3 because 5 cubed is 125. How do I go in number 2 from 2 to flipping it over and getting 1/8 as an answer? 2 to what power is 1/8? So what power would it be? The negative third power. So see if you can do 1 through 18 as kind of a warm up today. Know that on number 6, the base on number 6 needs to be a 10. That's called a common log. When you don't know the base, you can put a 10. So I'll give you a few minutes to just try. I'll put them up in a minute after I talk about number, which one did we say? 5 was tricky, right? So, yeah. So practice going back and forth for just a minute. Cannot be. I'm just going to rewrite these in exponential form, and then that way you can tell me the answer. Okay. All right, so let's just finish these up. So this would be what? I have to raise it to the fourth power, so the negative fourth should be the answer to number 3. I have to raise this one on number 2 to the third power and to the 0 power. And then, did you get these right? So the base, I just keep saying in my head, the base of the exponent becomes the base of the log. And these two reverse roles. The base of the exponent becomes the base of the log. The other thing that I've seen that helps a lot of students is thinking of it kind of like a circle. So the base to the outside power equals the inside number. 3 to the fourth power equals 81. So I just think of this is my base, I raise it to this power, and this is my solution. So thinking of it like a circle, so that you know what goes to what. So I draw that circle a lot of times when I'm evaluating logs. Okay, and then this I talked about, that the common log is just written log, and it always has a base of 10. We haven't talked about the natural log. On your calculator, you have 2 log buttons. You have this log button, and then you have this button underneath it called the natural log. This gets used a lot in calculus, but we're also going to use it in interest and in population growth. So these are both logs. They start with a letter L. People always want to tell me that that's an I. lowercase l for natural log. Log is natural. Natural base. So the natural base is E. E is called the natural number or the natural constant. Remember Euler's constant was 2.718? Because it's the natural base of compound interest and population growth. So on your calculator, I'm going to have you evaluate number 8, 9, 10, and 11 using those keys that are on the home screen. You don't need to do the change of base. So evaluate, like for example, if I do the log of 8 on my home screen, I get 0.2 decimal places. So like 0.90 is the correct answer for number 8. So round it to 2 decimal places. Try 9, 10, and 11. Does anyone know that was important when I was in high school, but it's not as important now? On these dinosaur calculators, the TI-83s, they didn't have the change of base built into the calculator. Now you have a change of base key. So what we were able to do was use the common log. I just want you to try one like this, using the log key that's on your home screen, taking the log of 8 and dividing by the log of 4 and showing me that that's equal to, if I change the base and do it all in one step. Because some of you on your home calculators or your phones won't have the fancy buttons. So you have to know it's like taking the log of that big inside number and dividing by the log of the base. Those come out the same. So you don't have to have a fancy calculator to do logs. You can do it on the scientific calculator has a log button. So if you take the log of 8 and, log of 8 divided by the log of 4, I get 1.5. If I do math log base 4 of 8, I also get 1.5. So whether or not you have a fancy calculator, as long as you know the change of base formula, you can do logs with whatever calculator you have. And then if you go back to when my parents were in high school in the 70s, they didn't have calculators with log buttons. So they actually used tables. So you'd have to like look up all of the log base 2 values from a table in their textbook. And so we're going to learn some properties of logs that were important when they were in school, but aren't quite as important anymore because they wouldn't have a log base 6 table. They would give you the log base 2 and the log base 3, and you would have to know what to do to those tables to make the log base 6. Because 2 times 3 is 6. So you could add the 2 values together, and adding gave you the multiplication to get to 6. So I feel like logs are getting easier and more accessible at the high school level because of the technology that we have. All right, could you finish by evaluating number 13? Did you already do that one? Do it one of the 2 methods. So what is the log base 3 of 2? So 3 to what power gives me 2? I just did the log base, but 0.63 is the answer, right? So we have to know how to type it into a calculator. Have to. I'm not helping you on that on a quiz or a test. On Tuesday's quiz, it'll just be no calculator. It'll be the ones from the front page of this. But for application problems, we're going to be cooling hot cocoa next week, figuring out the rate at which it cools, figuring out like a restaurant, how long does the pizza need to sit out of the oven before we bring it out to the customer so it's served at the correct temperature. So that's all dealt with exponential cooling, and you use logs to figure it out. All right, here is something that's a little bit challenging, finding inverses of exponential functions. So before I do those, can we quickly review what we did yesterday? How do I find the inverse of a linear function? What do I do to find an inverse? I have 2 ways that I can do it. What's the first way? Sure, so this is the algebraic method. Switch the x and the y, and then what would I do next to solve for y? So subtract 8 to the other side, right? Subtract 8. And then what would I do next? Divide by 3. So y equals x minus 8 over 3, if you want to leave it like that. Or 1/3 x minus 8/3, if you want to divide them by 3. That is what we're going to do over here. Because now we know logs are inverses of exponents. So I'd say this is kind of the next important step that if you can get it today, it would be great, but it takes a little bit of practice because it's inverse with exponents. So my first step is to switch x and y, and then y gets trapped in the exponent. There's no way to get it out of there. I can't divide by 6. I can't subtract 6. I can't divide by y, so I'm totally stuck. So in this unit, anytime you're stuck, you're going to convert from log to exponential form or exponential to log form. So I'm in exponential form. I'm going to move all those things around and write this as a log. So the base, remember, that becomes the base of my log, right? So log base 6. And then remember this is currently inside the function. Remember your inside and your outside numbers switch roles because it's an inverse. So the x goes inside the log, and that frees up the y. So now I actually have y equals, right? That is the inverse. If I wanted to, I could write it y equals the log base 6 of x. And then y equals 6 to the x. What's the second way that we learned we could find inverses yesterday? Do you remember? We graphed them, right? What did we say this was? Log base 6 of x. So here's my exponential curve. And then there's my, and it should continue like this. It's just hard to see the graph if this goes straight down. So remember, it's a reflection over the line y equals x. There's your exponential, there's your log, they're inverses of each other. So we can find inverses graphically or algebraically, but our key thing is whenever we're stuck, we have to switch from one world to the other. Logs or exponents. It's like translating French to English or English to French, right? Where do you want to, it's like a language. Fahrenheit to Celsius, Celsius to Fahrenheit. They are saying the same thing in another language. All right, 15. How do I find the inverse for 15? I switch x and y, and I try to get y by itself. So there is one thing I can do first to get y by itself. What would you do first? Subtract 1 from both sides. X minus 1 equals 4 to the y. Now I'm stuck because the y is stuck in the exponent. So if I'm stuck in exponential world, I'm going to rewrite it in log world. So the base of my log is going to be the 4 because that's the base of my exponent. And then remember, I trade whatever was inside the function, y is inside the function, is going to go outside, and whatever's outside the function is now stuck inside the log. So that actually is my final answer. This is the hard part, right? This feels really yucky to go from this to this. That's really hard concept to understand. The 4 is the base, and then these two things have flip-flopped roles. The reason this is useful is because now x is trapped, and I just got my function, y equals the log of this. Up here, I was trapped with my exponent. I couldn't get y out. So this is the first time that we can get y freed up. You try 16 on your own. Switch x and y, and see if you can get the y out of the exponent by switching to log form. So I switch x with y. I see if there's anything I can move to the other side. You should not have added 3 at this step. See how this plus 1 was outside of the function, minus 3 is inside the exponent. So it's actually at this step you're going to switch forms. Your base becomes a 2. The x goes inside your log, and you get y minus on the outside. So at the very, very last step, I'm going to add 3. So my final answer should be log base 2 of x inside the log plus 3 is my answer. So I added 3 to the other side, but then I rewrote it. Y equals log base 2 of x plus 3. And I think this is the hardest part of this unit. If you can get switching from logs to exponents, will be good. So did I switch the page question? Oh, why did I not put the x in parentheses? You could. Just because there was only one term. So here I wanted to show that the x and the -1 were both inside the log. Here it was kind of assumed that just the x is inside the log. But yet you could write it with or without a parentheses at that step. See, this one I had to put parentheses because I had 2 terms. Here I put parentheses to show that this plus 3 is clearly outside of the log function. But that's a question. So you can put parentheses on every single one. All right, last couple before lunch. This time we're finding inverses in the opposite direction. We're starting with logs. Our answer is going to end up in exponential form. It should feel easier this time. I think it's easier to go from logs to exponents. So your first step is x equals natural log of y plus 3. So all I did was switch x and y. I need there to be a base. So if I see a natural log, I can rewrite that as the log with base e, because there needs to be a base. If you're changing from log to exponent world, there has to be a base. So I'm going to put a base right here. My base is e. And now I'm going to rewrite this in exponential form. So the base is e. So the base of the exponent is e. And then remember, I just switched what's inside with what's outside. So x was outside the function. So x goes inside my exponent. E to the x equals y plus 3. And then I can't leave my answer like that. I'm going to subtract 3 to the other side. Y equals e to the x minus 3. So the minus 3 is like a downshift. This is going to shift the graph down. This would have shifted the graph left because it was inside a function. Inside, outside. All right, let's do one more, and then we'll do number 19 when we get back from lunch. So on 18, I switch x and y. So my first step is just to rewrite the x and the y have just traded places. That's an easy first step. The second step is to see what my base is. And if I just have log, the base that should be sitting there is a 10. So I need to write a 10 in my problem right here. Before I switch form, I really should move this minus 5 to the other side of the equation. So I really should have x plus 5 together before I switch into exponential form. And then can you see what exponential form would be? 10 is the base. I'm going to raise it to the x plus 5 power, and that will free up the y that's currently stuck in the log. And this is a graphable function. Y equals 10 to the x plus 5. We'll do the other one. You can cross out 20 and 21 because I'm not having you learn how to do those. But we need to finish 19 on this page because it was finding inverses. So I'd like you to try setting up 19 on your own because you should know that you're going to switch x and y. And then if you're in log form, you're going to switch it into exponential form. So take a minute and see if you can do 19 because it's the 6th example like this that we've done. So try to do number 19. Give you like a minute to try it. Because what we're finishing today is the content for Tuesday's quiz. We'll practice Thursday, we'll practice Monday, and hopefully we'll know our facts on logs. So switch your x and y, change it into an exponent. So I should switch the x and the y first. So I just rewrite it exactly as it was. X equals log base 4, y minus 1. Now I'm changing this into an exponent. So the base becomes 4, and the x gets trapped inside my exponent, and then I get y minus 1 over here. So 4 to the x equals y minus 1. Are you laughing thinking about the ones you're doing that? So then what would be my last step to get my final answer? I can't leave it like this. Add 1 to the other side. So y equals 4 to the x, and then I would write big plus 1. Okay, so the last piece that you need to be able to do, so just kind of flipping through this. First thing we did was just evaluate logs. That was without a calculator. The second thing we did was convert between exponent and log form, evaluating logs with a calculator, and then finding inverses of each other. So there's a lot of skills that we've got to work on with logs. The last one is graphing. I know that graphing is not your strong suit, but you did really well graphing exponential functions. If you can graph exponential functions, you're just flipping the points to graph the log. So it says, let's look at graphs of logs by using exponential inverses. So if you can make a table of values for 2 to the x, this is just going sideways, but this is our normal table, right? 2 to the 0 power is always 1. 2 to the first is 2. 2 squared is 4. 2 cubed is 8. And then if I go in the opposite direction, they just become reciprocals, right? 2 to the negative first is 1/2, and 2 to the negative second is 1/4. So this is just our normal table for 2 to the x. So we're going to graph 2 to the x first. So that's like what we did yesterday. So we're graphing 2 to the x, and then we're going to graph its inverse. Sorry, it's kind of faint to see those, where those points go. So there's my 2 to the x. So now it says, how can this table help us graph the log function? We're just going to switch x comma y and make it in our heads y comma x, right? The x's become the y's and vice versa. So I like to rewrite the points myself. So my x value would be 1/4 and my y value would be -2. And my x value would be 1/2 and my y value is -1, 1 0, 2 1, and 4 2. I'll leave it just at that. I really don't need the 8 3. So we're going to graph those points, and that will be our log graph. So I always start at 1. Just like with exponential, I always started at 1 on the y-axis, and I'm always going to start at 1 on the x-axis. And it's going to bend this way to the right. So whatever your base is, in this case, my base is 2 to the x. I go over 2 up 1, 3, 4, over 4 up 2. If you want to go over 8 up 3, you could. And then 1/2 and 1/4 go straight down. So purple is the original, blue is the inverse, and then remember it's a reflection over the line y equals x if you wanted to see the reflection line. And we also have an asymptote at x equals 0 because our original asymptote in purple was at y equals 0. Oh, and I guess I forgot to write, but if the base of the exponent was 2, what we graphed was a base 2 log. So whatever base you have, that's the log graph that you're going to get. If this was a base 3, we'd get a base 3 log, or a base 8, we'd get a base 8 log. So you use the exponential base of the log that you want to get. So the next graph is almost the same thing. Can I turn it now? Okay, so the next graph, what's the base of it? The base is 10 this time. So we're going to graph it and then answer these questions about the log graph. What are the 3 key points? So if I want to do 10 to the x, if you just use -1, 0, and 1, you're going to get the idea. What's 10 to the 0 power? And what's 10 to the first power? 10. And what's 10 to the negative first power? 1/10. Those 3 points are going to show you what this graph looks like. It's really stretched. This is exponential, so 0, 1, 1 comma 10, and then negative 1, 1/10. So it goes basically straight up. So those are the 3 points that we're going to flip to get our inverse function. Right? So I'm just going to flip these two. So for my log base 10 graph, I switch x and y. X is 1/10, y is negative 1. 1, 0, and 10, 1. And I think it's helpful to put the two tables next to each other. Okay, this is my exponential set of points. This is them flipped around. This is my log set of points. Because if you do it all in your head, you might make mistakes. No? So 1 comma 0, 10 comma 1, and 1/10. So very strongly sharp to the right because it's over 10 and up 1. So let's see if we can answer the questions about the log base 10 graph. So what are the answers about my blue graph over here? What's the domain and range of a log function? So think about, where is this asymptote? I'm going to actually highlight it in yellow, right? That's my asymptote that this blue graph is approaching. It's at x equals 0. So that's my asymptote at x equals 0. What's the domain? So instead of being all real numbers, x is greater than 0 because my x values go to the right. What's my range? My range is all real numbers because the original function had a domain of all real numbers. So when I flip it, now its range is all real numbers. So it's flipping the domain and range. My x-intercept, we said, was at 1 comma 0. Is this blue curve increasing or decreasing? So as I read it from left to right, is it getting higher or is it getting lower? It's getting slightly higher each time, right? So it's an increasing function. Discrete or continuous? It's continuous. I don't have to lift up my pencil. And its inverse is y equals 10 to the x. All right, so here are two log functions. The base keeps changing. So this has a base of 3. So I'm going to think in my head about 3 to the x. This one has a base of 4. So I'm going to think in my head about 4 to the x. What does this minus 1 do? And what does this plus 2 do? So does it go left, right, up, or down? X minus 1 would go right. What does this plus 2 do? Up 2. So it keeps reviewing your transformation rules. To me, it's too much to graph the exponential and the log and the transformation. So on these two, I'm just going to graph the original log graph. See if you can start to graph the original log graph. We always know that it goes through 1 comma 0, no matter what our base is. If the base is 3, think about what 3 to the x would have been. 1 comma 3. So we're going to go 3 comma 1. Over here, if it's 4 to the x, it would have been 1 comma 4. So I'm going to go 4 comma 1. So the base is how far you go over. So 3 comma 1 would be here. So that'd be my parent function. 4 comma 1 would be here. So those are the 3 parent points. And now you're just going to do what it says to do. So shift those right 1. This goes right 1. This goes right 1. This goes right 1. My asymptote also goes right 1 to x equals 1. So my asymptote changed because I moved to the right. And then this last one, if I move everything up 2, that moves up 2, that moves up 2, and that moves up 2. What was I at? Negative. I was at negative 1, so I'd be here. Something like that. So this keeps its asymptote at x equals 0. Maybe you can see my blue curve in there. So you need to be able to graph them, basically. And I would call these pretty simple, like one-step graphs using our like very basic exponential functions, 2 to the x, 3 to the x, 4 to the x. So I'm not going to kill you on graphing them, but I do want you to know your transformation rules. So this page is just a nice summary that you could look at on another day. This is the page. I'd like you to just do the, I'd like you to try A and B of each, and let's leave all the C's, and actually like leave half of each row. So like do A and B, and we'll keep C until tomorrow. But on 5 and 6, just do A. So if you can kind of keep the right side of the paper till tomorrow. That way we might have time to do one of Caden's games if we can get through. So do AB, 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 and then do just A on 5 and 6. Does that make sense? Take about, I don't think it'll take too long. Like these are really quick and easy. This is just typing it into the calculator. This is rewriting it in log form, so log base 5. All right, put that away. Do the A and B practice. Oh my gosh. Did you eat anything for lunch besides candy? That's a lot of pieces of egg.
Oh, yeah, the football. No, it's good. They're football. So they're basically Super Bowl. No,
Wait, 5 of them?
is it? No, it's not.
Yes! Oh, my belly hurts just thinking about it. But neither of those are my favorite kinds of candy. I can eat probably a bag of M&M's. I could not eat all those Reese's. Did you do any of it, Dylan? You did? Oh, Dylan. That'd be sad. Okay, do you need to know how to do this? Write it in exponential form. So what's the base of your log? 2. So the 2 is going to get raised to the y power. So 2 to the y. It says rewrite in exponential form, then solve for y. So they want you to write 2 to the y power equals 16. So what does y equal? Is that 4, right? Why are you using this kind of calculator? Use this one. You shouldn't need to know how to do it on these. You should have listened to the past hour.
But I have nothing.
Oh, no.
That's the test. That's the test.
Yep, good.
I didn't give you
Yeah, perfect. Yep, I just look back at this circle, add up to that, and yep. Hey, good, you know how to do this. Those are really cool skills in this unit. To be able to write them in. Yeah, yeah.
something you want to motivation and
Maybe
not
just
putting
write
work
5, 25, because 5 squared is 25. You don't do that, right? So which one do you need help on, Katie? Because these are ones, find the inverse. So you switch x and y. So you write x equals 3 to the y plus 5. And then you rewrite it in log form. So the log with a base of 3 of x trapped inside equals y plus 5. And then you subtract 5 to that log side. So log, can I write it though? So a base of 3 looks like this little guy, then the x, and then minus the 5. Yeah, okay. See if you can do, yeah, that's it. That's the inverse function. Oh, see if you can do 6a because it's the opposite of what you just did. It's starting out in log form and you're putting it exponential. Well, this is, oh, we already have it. Okay, so the tensor. Can you rewrite 0.01 as a fraction? How would you say the number 0.01? one time. So right there, 1/10. So 10 to what? Oh, it's 1/100. So 1/100. So 10 is negative. Oh, second. Yeah. So it would be negative 10. But if we're in this fraction, you'll see what happens here. I don't know if the x equals 16. You're trying to figure out what the actually equal y. Yeah, but you're trying to figure out what y is, right? 2 to y. Yes. No, there's no x. So 2 to what power is 16? This means you write 5 to y equals 1. Well, just because it's already white. Yeah. All right, so then you're putting 1 here and 1/36 here, so you can figure out what the power is. And you don't even have to do the these right now. So, yeah, and then this is good. 25 to 1/2 is 5. 5 squared is 25. You did this without looking, and then you can use on your calculator, right? Good. Logs are a difficult unit. So you feel like you're even starting to grapple with how to go between the forms. It's under math, and it's all the way down to letter A. On that one, you found it. Are you grasping on some concepts? This is not right. Did you do it on your calculator or? So it's a base of 10 equals what? So 10 to what power equals 1/100? Because that's the number 1/100. Which one? So you write equals 2. 5 squared is 25. You don't need this stuff. So then this would be 25. Oh, yeah. Wait, yeah, you're just rewriting it in exponential form. I don't know. So then, yeah, you just write equals. Yep. So that's right. And then this is, do you know how to plug those into your calculator and then you put out 5 there? That is under the math key on your calculator. You have to type it into the calculator. This is not 200. It's the regular log key right here. You just type the log of 20 in this case. And then this one is under the math key, and you go all the way down to math A, and I'll let you change your name. Where the page go? Right here. Okay. Are you okay if we do your game tomorrow, Kaden? You do your game tomorrow. Okay. You did the first step right, and then you did the second step right. That's good. And then you're going to change this into log form. You did. So you went from x to log. You're in a base 3 y. The x goes inside the log, and then equals y plus 5. Yeah, that's good. The last step would be just to subtract this 5 to the other side. Like, well, he's in right there. After the so just there's no equals to y. Minus 5 equals 1. Oh,
We're running out of time, Mr. President.
yeah, I said, well, what if you do it tomorrow? It's going to be 57. They're going to be not paying attention anymore. Yeah. Nice. I think it's log. Perfect first step. So now we're going to change this into log. So the log So starting to get the idea. So tomorrow we'll do some more practice. You know what? I never forgot about our schedule for tomorrow. So if lunch is based on our class, then we are going to go to second lunch. So you come to my class and leave, okay? But if lunch is based on fourth block, I'll just see you third block and then you're going to fourth block anyway. Does that make sense? Remember, because I asked this partner the schedule for tomorrow and you never responded. But I do think it goes 1, 2, 4, 3, doesn't it? On the schedule. And it said 1, 2, 3, 4. That's why I emailed them to say I think there's a mistake. Anyway, we're gonna go to second lunch if we have the option. If you guys need to lunch, we're gonna go to second lunch so you can walk out the door and leave. Okay? Okay. Come to me first, but if it's based on your fourth block, then not. Yeah, we're finally doing pre-calculus. Logs. Yeah. Woo, you made it. Polynomial functions is known. Rational functions definitely pre-calculus. Exponential is more accurate. But logs is a pre-calculus topic. And then the next one is series. Sequences is that topic that we probably need to cover again. Series is pre-calculus, and the limits is more popular. Pre-calculus is intermediate calculus. Did you pass in all of your regular stuff? Are you done now?
No, I wasn't here last week because
You were sick. Did you figure out you better now? No. But they like come to school today.
yeah, I'm not.
And you're still like feeling better? Oh, what are you doing?
I think it's also good.
Oh, because you thought you didn't. You thought you didn't.
Yeah, I was gonna lie.
You look bad.
No, it doesn't. Show up.
Anything else that your team has it? Or no? It may be then. I mean, at least you know. Right?
Haley, Elias,
Well,
and
I mean,
Melvin,
I'm not worried about
and
it.
Nathan is. Bye. Oh, Julia said she was up here, but she never stopped. You don't see her next block, do you?
She's actually probably coming down.
Oh. From Physics?
Yeah.
This total.